Hello everyone, welcome back to QuickMathics. I'm sorry for the starting way. I had to do some things after school that I cannot push back. But here we are. So today we're going to start Unit 4, Package 4. We're going to do functions. Let's get to it. Okay, what type of function is this one? X squared minus x plus 1. So first of all, every time you have, you need to when you're classifying a function, you need to go to look at the numbers that are over the x. So in this case, it's a 2. We don't have anything here, so it will be like a 1 because there's anything. And then here we don't have an x, so it doesn't count. So we have a 2 and a 1. And then we're going to look to the higher one. And in this case, the higher one is a 2. So this function needs to be the one that has the 2. And the one that has the 2 is the quadratic. So the answer for this case is quadratic. Now, if we're looking to square root, then the square root will be a square root of x. The exponential will be any number, I would say a, or you can put any number like 2 to the x. So the exponent, the one that is over another thing, is the x, and that's not what we're looking for. And then the linear will be x to the 1 or simply x. And in this case, we have it, but we need to look to the higher one. If we have one that is higher than that one, then that's not the answer. So, oops. Let's keep going. The equation of a function is shown. Which type of function does the equation represent? So here, we have x to the 3. So to the 3, it means cubic function. Why? Because quadratics is x to the 2. Exponential is something to the x. And absolute value is actually taking the absolute value of x. So cubic is the one that is to the 3. Now, the graph of a function is shown. Which type of function does the type which function type does the graph represent? Well, in this case, this is something that you actually need to know, but you get to know with practice. So first, the graph of an absolute value function. I have my s and my y, my x, and then I know that the graph of an absolute value function is like this. Does it look alike? No, so that's not what we're looking for. Now, A is not. Now the graph of a quadratic is this one. It's like a U. This is like the other, but it's circular. It doesn't look like this one, so we take it out. An exponential is something like this. Or more or less like this. Oops. But yeah, that's an exponential. So that's not what we're looking for. Then a cubic root is like this, which is exactly the graph we are seeing here. So that's our answer. Now, another way to do it is actually graphing the equation. Like, for example, they're asking you to graph an absolute value. Or if true or false, is this an absolute value? You're going to say, okay, an absolute value will be an absolute value of x. So I'm going to start plugging first. So I have my x and my y. And I'm going to start plugging. So when x equals 0, absolute value of 0 is just 0. So wait, 0 is going to be here. Now, x equals -2. Then the absolute value of -2 is 2 because the absolute value is just the answer in positive. Now, when x is -1, the absolute value is 1. When x is 1, we just keep the 1 positive, and when x is 2, we just keep the 2 positive. So if I do this, I say, okay, -1, 2, 1, 2, and then this is 1 and 2. Then I will say that my point is -2, so -2, -1, 0, 1, 2, 2. And then I can graph it and I get this, which is the same as drew before. So you can do that for every question that you can see. Like, you just need to know this is an absolute equation. A cubic rule needs to be this. An exponential is a number to the x, any number to the x, and then a quadratic is x to 2. Now, what type of function does the data suggest? Okay, first, to linear, it has to have a specific slope. So we can take this value, this point, and this point, and then this point, and this point, and the slope needs to be equal. So let's do that. Have the slope formula is y1 or y2 minus y1 over x2 minus x1. So I'm going to substitute the value, and I say 12.25 minus 3.5 equal to minus 1. So 12.25 minus 3.5, that's 8.75. Okay, let me check. Oops. Yep. And over 1, so it's just 8.75. That's our first slope, 8.75. Now, our second slope, let's just choose the two last numbers. It will be this big number, 22,518.75 minus 525.22. All of this over 8 minus 5. So we have this calculation. It's going to be 20,000, 21,000 something, 80 something, but let's see. 22,518 minus 0.75 minus 525.22. Yep. We get this big number. And then we need to divide it by 3 because 8 minus 5 is equal to 3. So we divide it by 3. And we get about 7,331 approximately. So 7,331. And you can see the difference of the slopes is very significant. So, of course, this is not a linear equation. Now, quadratic. So, something that we can do is actually plug in the data. That's what's going to be like my second approach. So let's do that. Have this actually all the numbers are positive, so and I'm going to make this. This is going to be 5, 10, 15. Actually, I need to start by 10 because then I won't have a space. So 10, 20, 30, 40, 50. I'm going to leave. Like, I cannot put the 500 will be like over here, and then the 2,000 all the way over here. So let's see. This is going to be is 1, 1, 2, 3, 4, 5, 6, 7, 8. So 1.3.5 going to be somewhere around here. Then 2.12.25 over here. 42.88 This is 3. Okay. Over here. Then 5 with 500 over here, and then 8 with 2000 all the way in the over, like over part of the paper. As you can see, this is going up very. It's not a. Okay, this is going up very, like, exponentially, as you can say. So I can, like, since it's not a straight line, I can take out the absolute value, because we just saw that the absolute value is a straight line, and then we are between exponential and quadratic. But since this is giving me these values, like any number, like this is for quadratic is elevated to square root, like to 2. So 8 times something elevated to 2 is not going to elevated only to 2. There's not going to be such a difference between this slope and this slope. Like it cannot be. Therefore, what we're looking for is to an exponential function, not a quadratic. Because an exponential function, for example, we're actually elevating a number to the 8. So it will be like any number, a number a, in this case, to the 8. Because a is the x. Now, the equation of a function is shown below. Which type of function does the equation represent? Write your answer in the box. Okay, so you can see here, this is an absolute value. It has the 2 lines. It doesn't matter that there is an x inside. So we are looking at absolute value equation. That's it. Or function. Actually, it's function. Now let's see 6. The graph of a function is shown. As you can see here, this is the graph. There are 2 lines that intersect. The 2 straight lines that intersect. That's basically what I have been drawing the whole day. I don't know why they love so much absolute value equations. But yeah, it doesn't matter that it's to the side. There just needs to be 2 straight lines right together. So, absolute value equation. Now, what type of function is this one? A square, a cubed root, I'm sorry, of x plus 3. So, as you can say, as I said before, this is of course not linear. We're looking to x to 1. This is of course not a square root because it's a cubed square, not a square root. It is not quadratic because we're not looking to x to 2. And as you can see, we're looking at a cubed root. This is basically square root, and you have a 3 here, which is a cubed root. So, B is our obvious answer. Now let's see. Which of the following represents the graph of a quadratic function? So now you should be familiarized with the type of graph. But if not, as I said before, like you can use this. Say, okay, I have, oops, I'm gonna say x, I'm gonna say y, line. I have -2, well, the function is x squared. Now, -2 squared is going to be 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Then therefore, if I do this, oops, if I do this, okay, I want it straight, more or less. 1, 2, 1, 2, 3, 4, this is negative, then 1, 2. And I draw my points, it will be this point, and I do this, I see that it's like a U. So D must be our answer. Now, number 9. What type of equation is this one? Okay, it's not linear because we see a square root in the x. It's not exponential because there is no number elevated to the x. It's not quadratic because we don't see x to the 2. It is a square root because this is a square root of x. It has the same name as the actual operation we are doing. Now, which of the following graphs represent a cubic function? Now, first of all, we know that b is not because it's an absolute value, and our cubic function is more or less the same as I was saying before. But in this case, it's x to the third. So we can use the values. We will say x, we say y, and I'm going to say -2, then -8, and negative to the third, like -2 times -2, 4 positive, times -2, -8. Now, and -1 to the third is just -1, 0 to the third is 0, 1 to the third 1, 2 to the third 8. You can use your graph and you can put it here. Wait. -1, -2, 1, 2, 3, 4, 5, 6, 7, 8. Then the same. And blah blah blah. And then up to here, -8. And then this is going to be 1. And this is going to be 2. Now, we plug in the values. We have 2 and -8. So here. Wait, let me use another color. -2, -8. -1, -1. 0, 1 and 1. 2 and 8. So as you can see, it's something like this. And now, this is exactly the same figure to you see here. And if you want to know, this is a cubic square root, like this. And then this is an exponential, so 8 to the x. Now let's do the next value, like the next exercise. Consider the value of values. Which type of function do the data suggest? So we can just go and graph it. I just think that's easier. So let's do that. Okay, we need like a lot of space in the upper part. So -4, -3, -2, -1, and 1, 2, 3, 4. Then I'm going to go like 5 from 5, from 5 to 5. So this is going to be 5, 10, 15, 20, 25 approximately. And we just continue the line. Okay. And now here we have, we don't need any, like we don't have a wide negative, so it doesn't matter. So now let's see, we have -4 with 9. So -4 with 9 is over here. -2 with 1. I'll be all the way over here. -1 with 0. Then 2 with 9. 3 with 16. And 4 with 25. And this is what you can see. So what do you think is this figure? We have drawn like many times. You can see that this is a quadratic because a linear looks like this. An exponential looks like this. And an absolute value is this one, which is any of the three. So let's continue. Consider the table of values. Which type of function does the data suggest? So this is just the same. We do the graph. I'm gonna do it right here. It's going from -2 to 4, so -2, -1, 1, 2, 3, 4. And then it goes up to 13. So I'm going to go from like 2. So 2, 4, 6, 8, 10, 12, 14. So we go now. It is -2 to 1, -1 to 3, 1 to 7, so 1 goes to 7, 2 goes to 9, I do this a bit here, and then 4 goes to 13. So actually, this is very straight. And to like prove that it is a linear graph, we can just do the slopes. So the slope from this one will be 3 minus 1 over -2 minus -1. So this is going to be 2. Oh, actually this is -1 minus -2. Sorry about that. It's going to be 2. And then this become -1 plus 2. Then which is 2 over 1, which is just 2. And then we can do the slope from these points right here. This is 13 minus 9 over 4 minus 2. So 13 minus 9, 4. 4 minus 2, 2. 4 over 2 is equal to. And we have the same slope. So it is a linear equation. Now let's see. Which of the following graph represent an exponential function? So, an exponential function, as I was explaining before, like this. But there are cases in which we can have negative a to the x. And if it is negative, you're actually going to get... Wait, I might have been explaining it wrong. Let me just go through. So as I was saying, in what I said before, I'm going to start over. So let's see. Which of the following graph represent an exponential function? Now, there are two types of exponential functions, which are the ones that x or the number is greater than 1, and the a, and the a is less than 1. When the a is greater than 1, we're going to have this. Now, when the a is less than 1, we're going to have this. And now, can you prove it? It's because of this. Let's see. I don't know, I'm going to say 2 to the, I'm going to say 0.5 to the x. 0.5 being my a. Now, I have my equation. Is x, y. I'm going to say x to the -2 So I'm going to go like x negative 2. I can go here and I say 0.5 to the negative 2 equal 4. Now x to the like 0.5 to the negative 1 equal 2. 0.5 to the 0 equal 1. Now 0.5 to the 1 equals 0.5, and 0.5 to the 2 equal 0.025 or 0.25. I think it's 0.025. I to the 2. Oh, it's 0.25. I'm sorry. 0.25. And as you can see, when we graph this, negative 2, negative 1, 1, 2, 3, 4, and 1 and 2. When I graph this, I have this 2 and 4, 1 and 2, 0 and 1, 1 and 0.5, 1 and 0.25, and is this figure right here. And as you can see, this matches with B. Now in this case, this is a cubic like x to 3, because that's the shape this function has. In this case, it's a quadratic equation, x to 2, and then in this case, it's the square root of x. And you can prove that by, graphing the equation. Let's continue. 14. Consider the table of values. Which function do the data suggest? Let's see. We can plug it in and see what we get. So let's do that. So we have forgot. So it's 1, 2, 7. So 1, 2. Wait. 2, 3, 4, 5, 6, 7. Wait. Now I'm going to say this is 1. This right here is 2. Trying to leave the same space between each number. Now say first 1, point 1.1, like comma 1.1, then 2, comma 1.21, then 3, comma 1.331. It's a little bit lower, this a little bit lower. Now 5 times 1.61, 611, and then 7, 1.949, so almost 2. So the equation that we have is something like this, but I don't see it as a straight line. See kind of a pattern here. Maybe it's me, but let's just calculate what we think. I think we will have square paper is like a lot easier. I might actually get square paper to put it here so we can graph better, because this is not how can I say it? This is not like how it should look like. And actually, I don't know if you guys can in the test use a graphic calculator, but let me show you how that graphic calculator will look like. So we can go in this example. I'm going to use decimals, but I have a graphic calculator. That you can to like go to the table and put in the values. So it will be 1, 1. Okay, the x will be 1. Well, okay, I need to use this. I'm sorry. 1, 2, 3, 5, and 7, right? 5 and 7. Yep. And then the y's will be 1.1, 1.21, 1.331, 6, 11, 9, 49. So 1.611, 1.949. Oops, it was 0 instead of 1. And then you can see how it looks like really. And it does look kind of linear, but at the same time, I don't see the same slope between each point. Let's just calculate it there. So let's use this point and this point. It will be 1.21 minus 1.1 over 2 minus 1. So this will be 0.11 over 1, which is 0.11. And then in this point, it is 1.949. Oops. Minus 1.611 over 7 minus 5. So this equals 0.338 over 2. And this is 160, like 0.169, if I'm not mistaken. And as you can see, the slope is very different from one another, so it is not linear. It actually increase a bit. As we can so we get out of linear. If it's not linear, it cannot be as a value. Now we have exponential and we have quadratic. And sincerely, I see what I kind of see is like a curve going a little bit down. I simply not sure though. Okay, screen right. So if I connect the points, they are not a straight line. Like if I draw a straight line, it's going to be a little bit over. This is a way to make sure it is not a straight line. It's passing through one point and not to the other. Basically this. And I can say that I see that it's a bit be going up. But so I think this is exponential. Because there is no for b quadratic, it should be increasing at the ratio of the slope should be increasing at a fixed rate. So we basically need to calculate all the ratio of all the slopes. So the first slope is 0.11. The second slope, we can just go to our calculator. It's a lot easier to do in the calculator. So, you know, okay, okay. It's not working like that. Okay, I have another calculator that works better, but the upper one, like the y2, so 1.331 minus 1.21 over the difference of these two, which is only 1. As you can see, this is 0.21. Now let's see the ratio of the slope of the second one. So it's 611, and so 1611 minus 1331. And then 5 minus 2, 5 minus 3 is 2, so we divide it by 2 and we get 0.14. And then this ratio we also are going to divide by 2, but now is 1.949 minus 1.611. And we divide by 2, we get 16.9. 0.169. Now the difference between this and this one is 11. Difference between this one and this one, like it should be like one in the middle, so it should be twice 11, so 22. But if we divide 14 minus like 0.14 minus 0.21, this is 9, like 0.09. And the difference in this case should be wait, this is 0.011. The difference should be 0.022 because there is a 4 right here. I don't know if I explained it right. I'm gonna post a video. I really mess up sometimes with functions. So yeah, our value is exponential. So in this case, consider table the value with a function does the data suggest. Let's see. We have up to 16 in the y, so let's make a big y. X -2, -1, 0, 1, 2, 3, 4, 5. Whoa, 5. I'm going to put by 5, so 5, 10, 15, -5, -10, -15. I'm going to graph, so -2. Oh, there's a 22, so -2, right over here. It's a little bit down, yeah, but you know. So over here, -1 times 16.5, 0, 11, 3, -5.5, and then 5, comma -16. And as you can see, I see this trend. Oh, wait. So something like this. And what I can think of something like this. Wait. It's not a line, but there's a certain curve here. So we know that it is not a line, although it might be. You know, if we don't have like square paper, just find the slope because it's difficult to see there. We can use our graphic calculator or whatever. We don't like some of us don't have one. If it is in your phone and we're not going to use our phone for the exam, so let's just calculate the slope. In this case, the slope will be like 16 minus 22. Oh wait, let me do this. 16 minus 22 over, put the parentheses, -1 minus -2. So -1 minus negative. So minus minus is positive, so plus 2. And we get that it is 6, like -6. So -6. Now 11 and 16.5. Oh, this was 16.5. My bad. So it's -5.5. Now 16.5, 11 minus 16.5 dividing by negative, 0 minus 1 is plus. So we get the same slope. Now the next one. So negative 5, negative 5.5 minus 11. Yes, divided by 3 minus 0. Negative 5.5. And then 5 and negative 16, so 5, 5, 3. Then we have negative 16.5 minus 5.5, so plus. And this one minus. Oops, 5.5. And this is negative 5.5. As you can see, they all have the same slope. So if they all have the same slope, this is a linear equation. And I think that's all for today. I'm going to post a video explaining a little bit better since I kind of screw up sometimes. Thank you for listening, and don't forget to ask me any questions in the Discord channel.